Hi there. So in this video, I'm looking to give you a preview of how to calculate intervals of increasing and decreasing, as well as what are the points for relative extrema. And relative extrema is really just fancy terminology for finding your maximum and minimum points. And hopefully maximum and minimum points will be very intuitive for you because we think of a maximum being a higher point on the graph, a highest point on the graph, and a minimum to be a lowest point on the graph. Now, the exact definitions for these terms will be identified in your Math 171 notes, but like I said here, I'm just looking to give you an overall broad preview of that material, okay? First couple of questions at the top, I'll let you take a look at and compare to the solution key. I just want to go ahead and dive right in down here below, okay, below the graph itself. Here it says to identify the maximum and minimum points on your graph by placing stars by those points. So hopefully you would agree as we look at this graph up here at the top that, okay, well, here at low tide, that's a lowest point. So I'm going to star that. That seems to be a low point, a minimum point. And then you follow that up to high tide, star that, because that would be a maximum point. Follow that back down to another low tide. And it says, well, then what happens to the tide at these points? And hopefully you would agree, the tide reaches its highest and lowest values. Highest and lowest values. And then it says here down below, it says, notice that the maximum and minimum points are exact points on the graph. Then below that it says, well, could you label these points with an XY coordinate point then? And sure, we could do that. I'm going to start here from left to right. Your first order pair then, it happens at 3:45 a.m. And I'll just put the a.m. underneath it. You have a low tide, 0.1 feet. And I won't worry about putting the feet there. We know those are in feet. But the a.m. and p.m. changes on us. Then we move to our high tide. That happens at 10:09 a.m. and it has a height of 2.9 feet. And then follow that down to the next low tide at 4:37 p.m. and it has a low tide of 0.1 feet. Okay, so those would be the ordered pairs that would identify those lowest and highest points, or as we move forward, we'll label these as relative maximum and minimum points. Essentially where your graph changes from increasing to decreasing, okay? Below that, it says, now let's draw some arrows next to the graph moving from left to right. So if I start here on my graph from my low tide and I start drawing arrows to get myself to high tide, notice what those arrows look like, right? They keep getting taller and taller, right? They're increasing. They're going like so to our highest point. And then on the other side of that high tide, to draw arrows leading me to my low tide, notice that my arrows start to decline. They are decreasing to that low tide. So to summarize that, hopefully you would agree here that the graph is increasing when and where our arrows point upward, and our graph is decreasing when or where our arrows point downward. So that is certainly a technique that you can use to help you identify your intervals for increasing and decreasing. So just below that, we're going to actually put these intervals as an ordered pair. We'll talk about in our 171 class all intervals for increasing, decreasing, and we'll also talk about constant are always written with parentheses. You'll never have a bracket when you are identifying intervals for increasing and decreasing and constant, okay? You can have brackets when you talk about domain and range, but not with increasing, decreasing, and constant. Below that, it says, let's describe in words when and where the graph is increasing. So we said, well, you're increasing where your arrows are pointing upward. So I'm increasing then from 3:45 a.m. to, I get to that high tide of 10:09 a.m. So in words, I would say, okay, I'm increasing from 3:45 a.m. to 10:09? Yes, 09 a.m. As I've mentioned, this can be written in interval notation, and this interval of time would be from, and we would write that as 3:45 a.m. to 10:09 a.m., like that, okay? Using parentheses. Again, increasing and decreasing, we'll always use parentheses. I'll draw this, this next piece here to your attention. This looks like an ordered pair, right? Because it's like an X comma Y. But don't confuse that here. Remember, this is interval notation, okay? It is not an ordered pair, okay? It is going from one X value to the next X value. It's going from this low X value to my first maximum point highest X value. Just below that, it asks for us to describe in words where our graph is decreasing. So that's where our arrows are pointing downward. So we can say, okay, well, I'm decreasing then from 10:09 up until I get to this lowest point here at 4:37. So I would say that I'm decreasing from 10:09 a.m. Insert that. There we go. To 4:37 p.m. Okay. Again, they want us to now write this interval of time in interval notation. So we'll write that as from 10:09 a.m. to 4:37 p.m. Okay. And then I'll draw your attention to the starred piece down at the very bottom, because that's super important. You'll notice here that whenever we were talking about our increasing and decreasing, we never talked about how high or how low the tide was. We weren't worried about the y-axis. We weren't worried about the height of the tide. We were always focused on our x values. When was the tide increasing and decreasing? So just like whenever we have read for our domain and we were only concerned about our x-axis, the same is true whenever you pick out intervals for increasing and decreasing. You are only focused on your x values. You're not concerned about the y-axis. And really, the only time you're concerned about your y-axis is when you're reading the range, okay? Let's flip it on over then to the next page, and let's do an example. Let's do example 1 here together, okay? So a couple of things that I like to do whenever I am identifying, in this particular problem, we're going to be identifying increasing, decreasing, relative maxes and mins, domain, and range, okay? I like to come over here on the left-hand side and say, okay, well, x values over here represent negative infinity, and on the right-hand side, x values over here represent positive infinity. Because if you keep continuing on to the right, then you're going to positive infinity, and if you keep continuing on to the left, you're going to negative infinity. Okay. In example 1, it says label the maximum point and then draw arrows to indicate where your function is increasing and decreasing. So hopefully you would agree up here, this tippy top point, this would be referred to as a maximum. And as we put our arrows on our graph, we're going to approach this graph like we read a book from left to right. Okay, so as I, hold on just a second, let me get that shifted on me. There we go. All right. Let me put my arrow, as I read this graph from left to right, coming in from down here, I am increasing, increasing, increasing until I get to this tippy top maximum point. And then on the other side of that maximum point, I start going down. So I am decreasing, decreasing, decreasing. Okay. So remember, when we go to start identifying our increasing and decreasing intervals, we're going to be focused on, okay, well, if our arrows are pointing upward, then we're increasing. If our arrows are pointing down, we're decreasing. All right. So I think we're ready to do that actually. So just in part A, it says identify your intervals where your function is increasing. So that would be this portion of the graph right here, right? Because those are where all of our arrows are pointing upward. So I want to write that in interval notation, just concerned about my x values. So x values on this side, since they're coming in from the bottom here, they're coming in from, I don't want you to confuse with the y-axis. They're coming in from the left, and so your x values over here from the left are negative infinity to this tippy top x value up here, and that x value is 0. And then, like I said a minute ago, intervals for increasing and decreasing are always going to have parentheses. Now, next up in part B, it says it wants us to give the interval notation where our function is decreasing. So from that tippy top point, on the other side of it, notice how all the arrows on this side are pointing downwards. So this is my decreasing side. This was my increasing. Over here now is my decreasing side. I want to write this in interval notation. So I'm picking it up at 0. And then I go down and to the right forever. And remember, I'm only worried about my x values, and so going to the right forever is positive infinity. Parentheses on both. Okay. Letter C wants us to identify any relative maxes or mins, and we've said, okay, well, we got a tippy top point up there, so that's a relative max. So I have a relative max at 0, 4. That's not interval notation. I'm just going to put here, this is an ordered pair. Okay, that's actually identifying that point on the graph. Letter D and E want us to go back and talk about domain and range. So remember, with domain and range, we can use parentheses and brackets depending on what needs to be utilized here. So in letter D, it wants the domain. So my graph, domain, remembers reading your x-axis. My graph goes down and to the left forever, so it's going to the left forever. It's going down and to the right forever. So since it's going to the left and to the right forever, we can say that our domain then is negative infinity to positive infinity. Remember, infinities always get parentheses. Letter E wants the range. It's the only time we read the y-axis. So read it from bottom to top. And as we look at this graph, try it again. As we look at this graph, coming in from the bottom, this graph comes in from y values down here, negative infinity, up to this tippy top y value up here, which is positive 4. So we can say then that our range is from negative infinity to positive 4. Infinity always gets a parenthesis. You can equal that 4 up there, so it gets a bracket. Okay. I encourage you now to pause the video and try example 2 because it's very similar to the one that I just ran through, and then you can check yourself by the solution key. And then I'd like to do one more with you, so I'm going to flip it on over to example 3. In example 3, we'll start here by first, I'm going to come over and label my x-axis. On the left-hand side, these are negative infinity. On the right-hand side, positive infinity. Because remember, that's the majority of how we read our graphs, along the x-axis. And let's go ahead and identify our maximum and minimum point. So as we sort of start tracing this graph, I am going up. So I'm doing my up arrows, up until I get to this point up here. So let me star that point there. That's going to become, since that's a tippy top point up there, we'll be able to label that point as a maximum. And all of those arrows are pointing upward. So we're going to know that this is a interval for increasing. When we get to that in a few moments. Then on the other side of that maximum point, keep tracing your graph. Oh, we're going down again. So we go down until we get to this low point here, and this would be referred to as a minimum point. And then on the other side of that minimum point, my graph turns around and starts going back up. Okay. So in part A, it says identify the intervals where my function is increasing. So I'm increasing anywhere that my arrows are pointing upward. So here's one interval. So x values over here on the left are negative infinity to that tippy top x value, negative 2.5. Always get parentheses. Unite that, there's another portion of your graph that also has upward arrows, so it's also increasing. The x value associated here would be 0, and then it's going up and to the right forever and going to the right forever, positive infinity. Those would be our intervals here. We've got more than one where you're increasing in this particular graph. And then part B wants us to do your intervals for decreasing. There's only one of those, and that would be this leg right here, leg of the graph where your arrows are pointing downward. And I just need to go from x value to x value. So from negative 2.5 to 0. That's where I'm decreasing. Letter C wants us to identify our maximum and minimum points. So we'll just put that down here we had a relative minimum at 0, 0. And we had a relative max at negative 2.5, 3.75. Again, those are ordered pairs, actual points on the graph. D and E want your domain and range. So domain, you're reading your x-axis from left to right. This graph goes down and to the left forever. It goes up and to the right forever. So since it's going left and right forever, my domain will be negative infinity, positive infinity. It's going down and up forever. My range will be the same. So negative infinity to positive infinity on both of those. And then we'll finish up here at the bottom by looking at specific points on the graph. In letter F, it wants us to find f of negative 2.5. So remember, it's saying when x is negative 2.5, it wants us to find y. So we come up here to our graph. When our x is negative 2.5, our y value is 3.75. And that'd be your final answer. Letter G, when your x is 0, it wants you to find your y. So when x is 0, our y value is also 0. And then the last one, when x is negative 3.5, your y value is also 0, right? Negative 3.5 here for my x, my y value is 0. And then lastly, in part I, it wants us to find all x such that f of x equals 0. So remember, f of x is the same as y. So it wants us to find whenever y equals 0, find all the x's for where y equals 0. So when y equals 0, your x could equal, there's a couple of spots, right? When your y is 0, right here, your x is 0. When your y is 0, your x is negative 3.5. So, final answer here, x could equal negative 3.5, and when x equals 0. So when x equals negative 3.5 and when x equals 0, your y is 0. Okay. All right, I hope this helps, and we'll take an even deeper dive into this whenever we look at this particular section in your 171 class. Thanks a lot. Bye.